Shallcross. I'm a Professor of Atmospheric Chemistry at the University of Bristol, and I'm also Director of the Primary Science Teaching Trust. My area of research is air pollution, atmospheric chemistry and climate change, and I'm going to be spending a bit of time talking about climate change. The main driver is the sun. That provides the heat energy that warms the planet up, and most of that energy from the sun passes through the atmosphere and arrives at the surface of the Earth where it warms it up. A little bit of the energy, very high energy radiation, is removed by ozone and O2, oxygen in our atmosphere fortunately, and that stops us getting skin cancer. But it removes the harmful radiation, but the UV, the visible light that passes through, warms the Earth up. So that starts off the system. However, as many of us experience, there are clouds in the sky and there are ice at the polar regions and across the planet, and that reflects this energy from the sun back out to space. It acts exactly like a mirror. And if you then take that into consideration, we lose 30% of the energy from the sun just by this cooling process. And if you do the calculation, the surface temperature of the Earth should be minus 18 degrees. And clearly that's not the case. So there must be another mechanism, another factor that is warming the surface of the Earth back up again. And that is a greenhouse gas. And these greenhouse gases are able to capture that energy, if you like, absorb that energy and radiate it, pass it, transfer it back down to the surface. And it is literally like acting like a blanket. So these greenhouse gases are in the atmosphere in tiny, tiny quantities, and yet they play a disproportionately important role. And as I said, without natural levels of these greenhouse gases in the atmosphere, the Earth system would be uninhabitable. The human activity, will generate greenhouse gases. When we breathe out carbon dioxide, which is an important greenhouse gas. There are other things that we do which we don't talk about. We do generate methane, and I'll leave you to wonder how we do that, but that is also an important greenhouse gas. We are burning fossil fuels which contain carbon, and as we burn these fossil fuels, they generate carbon dioxide. Through agricultural practices, we use a lot of fertilizers, and that can generate other greenhouse gases like nitrous oxide. There are lots of natural systems that also generate greenhouse gases. The simplest way of explaining how we make these measurements is if I'm sure people have done an experiment where they've taken a piece of paper and they've taken a pen and put it on a piece of paper and then added water to it and watched as the ink runs. And if the ink is made up of a mixture of colours, then those colours are separated, and that's something called chromatography. And basically what we're doing is we're taking in large volumes of air into an instrument, and we're then separating out all the different components of that air using chromatography. So actually a chromatographic column is separating out all the different components of the air, and then we're using something called a mass spectrometer, which literally weighs the different molecules, and from the different weights of the molecules we're able to work out which molecule it is that we're looking at. And by calibrating the instrument, we're able to work out the concentration. One of the things that we're doing in the group that I work in is to measure the changes in the levels of greenhouse gases in the atmosphere. We do that by having a network of 8 or 9 research facilities across the world that make hourly measurements of a whole range of greenhouse gases, and from the analysis of these measurements we're able to work out how the concentration of these gases are changing with time, what is causing that change, and what the impact of that change will be. I would like to say, given this opportunity, is that it's really important for the next generation of young people to get interested in science and engineering so that they can contribute and save the Earth system by coming up with innovative ways of producing energy without generating greenhouse gases. But it is actually not a story of doom and gloom. We can offset, we can steer away from this.